Hello students, in this video we are going to discuss about the group 13 elements which is commonly called as the boron family. Boron families, in this the group 13 elements which is called as boron family, the elements involved in these groups are boron, aluminium, gallium, indium and thallium. So let us discuss more about these group elements. First, let us discuss the occurrence of these elements. In this, the boron is the fairly a rare element. Mainly it occurs in the nature as a orthoboric acid. The formula for orthoboric acid is H3BO3. Borax, the formula is Na2B4O710H2O and the form of kernite. So in the nature, boron is existing in these forms. When we talk about aluminium, aluminium is the most abundant metal and it is the third most abundant element in the earth crust. So it is formed abundant in the nature, that is in the earth crust it is a most abundant metal. It is available in the nature in the form of bauxite. The formula is Al2O3 twice H2O. In the form of cryolite also it is available. So bauxite and cryolite are the important minerals of aluminium. Next, about the other members like gallium, indium and thallium. These are quite less abundant element in the nature. It is found in the very low percentage in the nature. So these elements, gallium, indium and thallium, in compared to the boron and aluminium, they are less abundant in the nature. When we talk about the electronic configuration for these elements, when we write the electronic configuration for these elements, we can see that there is a similar pattern of electronic configuration. That is, in which the last electron is in the p subshell. That is, in the case of boron, it is in the 2p. In the case of aluminium, it is in the 3p, then next 4p, 5p, 6p, and only a single electron is there in the p subshell. So what we write the general electronic configuration for this one? Because the electron that is present in the s, that is also an outermost electron, because this electron is in the outermost shell, because here in this case 2 is the outermost shell for the case of boron. So here the 2 electrons are in the s orbital and 1 electron is in the p. Therefore it is need to write both the electrons, you need to write in the general electronic configuration. So what will be the general electronic configuration for these elements? That is Ns2 Np1, where N is the principal quantum number, that is the last shell, outermost shell. In the case of boron, the outermost shell is 2, that's why it is in the second period. Aluminium is in the third period, because when you write the electronic configuration, it is 3s2 3p1. That is 3s2 3p1 means what will be the value of N here? It is equal to 3. That means it belongs to the third period. Similarly, when we look at here for the case of gallium, it belongs to 4th period, indium belongs to 5th and thallium belongs to 6th period in the periodic table. Next, when we talk about the atomic radii, as we know that top to bottom atomic radii increases, because at each stage what happened, the number of shell is increasing. So when the number of shell is increasing, we can say that the atomic radii increases. Next is the ionization enthalpy. As size increasing top to bottom, that's why the ionization enthalpy decreases top to bottom. That is important to note. Size is increasing top to bottom, but the ionization enthalpy decreases top to bottom, because we have learned the relation of size and ionization enthalpy. Greater the size, lesser will be the ionization enthalpy. But these elements can lose 3 electrons. That's why aluminium can form 3 positive charge. That means it can lose 3 electron from its outermost shell. So the enthalpy change due to the loss of first electron, that is called as first ionization enthalpy. The enthalpy change when the second electron is lost, then it is called as second ionization enthalpy. And the energy change takes place when the loss of third electron takes place, that is called a third ionization enthalpy. And when you compare first ionization enthalpy, second and third, third will be greater than the second, second will be greater than the first. That we have already discussed. In order to remove the electron from the neutral atom is easier, but from a positively charged species it will be quite difficult to remove the electron. So the order of ionization enthalpy, it is expected to this as third ionization enthalpy is greater than the second, second is greater than the first, and the sum of the first 3 ionization enthalpy for each of the element is very high. So this will affect the chemical properties that we'll be discussing later. So this is all about the general properties of a group 13 elements, that is called as boron family. So the details of these, that is physical and chemical properties, will be discussing in the next video. So this is all about this video. Have a nice day.